Let's take a look at an example where we want to estimate the variance and standard deviation of stock returns. It had the following annual returns over the past 5 years. They were 8%, negative 15%, 22%, 14, and negative 10. So we want to estimate the variance and standard deviation, or if the question said what are the variance and standard deviation, we have a sample of 5 actual returns. So we want to estimate and compute the sample variance and the sample standard deviation. Again, note that it doesn't really matter what the order is as far as whether this was 5 years ago, the first year, the second, the third, the fourth, the fifth. It could be a random order. You wind up getting the same variance and standard deviation. One of the things that I find often helps folks is to use a table, because the equation for variance has a lot going on. It's got averages and subscripts and superscripts and 1 over n's and 1 over n minus 1. So a table is a really good way, especially when folks are first working on these kinds of things, to compute sample variance and sample standard deviation. So the first step in a table is to set up a column with the annual returns. So you got 8%, negative 15%, 22%, 14, and negative 10. And the weight for the mean is 1/5. There's 5 returns, and so when we get the mean, it's adding them all up and dividing by 5, which is the same as 1/5 times the first, plus 1/5 times the second, plus 1/5 times the third, plus 1/5 times the fourth, times 1/5 times the fifth. So we can get 1 over n. In this case, it's 1 over 5. And then we can get the mean simply as 0.2 times 0.08, which is 0.016, plus 0.2 times negative 0.15, which is negative 0.03. 0.2 times 0.22 is 0.044. 0.2 times 0.14 is 0.028. 0.2 times negative 0.1, negative 0.2. Add them all up, and the mean is 3.8%. So again, all we've done is made a table where the mean, which is add them all up and divide by 5, which is the same as 1/5 times the first times 1 plus 1/5 times the second, all the way through to 1/5 times the fifth, is what we've got there. Now we want to get the deviation. So if the return here was 8% and the mean is 3.8%, then the deviation is 4.2 percentage points. So 8%, again, you can think of it if we have a number line here, and let's say that's 3.8%, 8% here, it was 4.2 percentage points above 3.8. Here, if we're at negative 15, so negative 15 is way over here, we basically, and the mean was 3.8, we undershot it. That year it was 18.8 percentage points below. That was the deviation. Next year, 22%, the mean's 3.8, so 22% is 18.2 percentage points greater than 3.8. 14% is 10.2 percentage points greater than 3.8, and negative 10 is 13.8 percentage points below 3.8. And so again, it's just the annual return minus the mean. 8 minus 3.8, negative 15 minus 3.8. I tried to give some context that, pick one like, 14%. If the mean is 3.8, it was 10.2 percentage points greater than the mean. So that's the deviation. And you can see some are positive, some are negative. Now we want to square them. Again, they're all positive, and the bigger the magnitude of the difference between the return and the mean, the bigger the squared deviation. So now we have 5 squared deviations. The variance can be thought of as the sample squared deviation, the standard sample, the standard squared deviation. So we want to kind of come up with a way to kind of get a typical of these 5, but there's a statistical penalty, and so the weight on each of them isn't 1/5, it's 1 over 5 minus 1, which is 1/4, which is 0.25. So it's 0.25, and then we just take the weight times the deviation squared, the weight times the deviation squared, the weight times the deviation squared, and you do that for all 5 terms. Add them all up, And there is your variance, 0.02492, which is the same as adding up all 5 deviation squareds and dividing by 4. Now you want to get the square root, so you take the standard deviation, you get the square root of the variance, 15.79%. If you use the tables, the mean, if you use the formulas, the mean is just add up all 5 returns and divide by 5. You can do it in decimal format as well, and you get 3.8%. The variance, there's 5 returns, so for each term it's 1/4 times the deviation squared, which is the return minus the mean, 1/4 times the return minus the mean squared, 1/4 times the return minus the mean squared, plus 1/4 times the return minus the mean squared, plus 1/4 times the mean minus the return squared. And that's the variance of 0.02492. Alternatively, you can add up the 5 deviation squared terms and divide by 4, take the square root, and you get 15.79%. So the table that we just went through step by step by step is just a way of kind of formalizing that process and breaking it down into the different steps. But the bottom line is, if you are comfortable working with this expression, knowing that the mean comes from there, then you're good to go.